Welcome to This Explainer. Okay, today we are looking at something absolutely monumental. For decades, we thought of the internet simply as a tool. It's just a place we visit to check emails, stream movies, or look up information. But we are standing right on the edge of a massive paradigm shift. The future internet won't just be a faster version of what we have today, with, say, quicker Wi-Fi and better fiber optics. No, it is evolving into a fundamentally new digital ecosystem, a truly ambient network connecting absolutely everything around us.
So here's a massive question to kick things off. What happens when literally every physical object, every autonomous vehicle, every artificial intelligence system, and eventually every single person is constantly, invisibly connected? The internet already connects more than half of humanity, which is wild to think about. But by 2050, it is projected to connect almost everything on the entire planet. And the answer to this question isn't just about technology anymore. It could fundamentally redefine human civilization itself.
All right, let's dive right into this. We'll start by mapping out the evolution of connection, then explore the new intelligent network, followed by the immersive web. After that, we'll tackle some of the great digital challenges, and finally zoom all the way out to an interplanetary nervous system. Let's start at the beginning with Section 1, the evolution of connection. Let's look at exactly how we got to this pivotal moment. The journey so far has been nothing short of incredible. Back in the 1960s, ARPANET brought us basic computer-to-computer communication. And hey, fun fact, that initial system famously crashed the very first time they tried to type the word login. Kind of hilarious, right? Moving through the 2000s, broadband and smartphones put the entire internet directly into our pockets. Then, in the 2020s, global fiber optic cables and cloud computing made heavy data instantly accessible pretty much anywhere. Every single generation of the internet expanded what humanity could accomplish. But by 2050, we hit the ambient network. The internet completely stops being something you actively log into and instead becomes an invisible, always-on utility just pulsing in the background of daily life. But here's the thing. Faster internet isn't actually the biggest change coming our way. Surprisingly, the primary user of this next iteration, it's not going to be human. It will be artificial intelligence. AI is rapidly shifting from being just a handy tool on the network to actually being its primary resident and operator. And to support all these new AI residents, we're going to need an entirely new architecture. Welcome to Section 2, the new intelligent network. So, the crucial point here is understanding the deep contrast between today and tomorrow. The current internet, it's user-driven, it's screen-based, and it's highly reactive. You click a link and a server somewhere responds. Simple enough. But the 2050 internet will be AI-driven, ambient, and highly autonomous. Now, doing this requires entirely new infrastructure. We're talking 6G, ultra-low latency connections, and this fascinating concept called edge computing. Edge computing basically means data is processed right where it's generated, like inside a self-driving car or a smart traffic light. Think of it like keeping a fire extinguisher right in your kitchen, rather than having to call a fire department 3 states away every time there's a spark. It saves these crucial, life-saving milliseconds. Intelligent routing will allow the entire network to manage itself, constantly adapting traffic flows in real time without any human intervention at all. Now, this autonomous network enables a seriously incredible concept called digital twins. A digital twin is exactly what it sounds like, a highly detailed, real-time virtual replica of a physical object, a factory, or even an entire smart city. By 2050, our physical infrastructure will mirror itself perfectly in the cloud. Just imagine this. City planners could literally simulate a Category 5 hurricane hitting a virtual coastal city, measuring structural stress and testing traffic evacuation routes digitally, long before a single drop of real rain ever falls. But sustaining these digital twins and all those autonomous AI agents requires absolutely unimaginable power. Based on telecommunications research from groups like Gartner and Cisco, AI computing demand is going to skyrocket by 2050. This will be driven heavily by autonomous transport, smart cities, generative AI, and predictive healthcare. Think about it. Every single self-driving car and robotic surgeon requires split-second, flawless data to function safely. It creates an absolutely insatiable demand for processing power. And the financial scale of this transition? It's staggering. We are looking at over $10 trillion in projected infrastructure spending over the coming decades. Major organizations, companies like Google, Microsoft, Amazon Web Services, NVIDIA, and Meta are pouring unprecedented capital into laying millions of miles of new fiber, launching vast satellite constellations, and building massive data centers. They are actively constructing the physical, AI-native backbone of tomorrow right now. So that's the macro level. But what about us? Let's explore Section 3, entering the immersive web, and see what life looks like beyond the screen. Believe it or not, we are actually on track to abandon traditional smartphones entirely. Step 1 of this transition is extended reality, or XR glasses, seamlessly blending the digital and physical worlds in our everyday vision. Then step 2 is spatial computing. This is where your digital workspace isn't just a flat screen, but your actual physical environment, filled with digital elements and virtual collaboration tools. And step 3? That is the ultimate frontier, brain-computer interfaces, or BCIs. Ongoing research suggests we could eventually bypass physical interfaces altogether. This would allow direct neural connections to the internet, where you might query a search engine using literally nothing but your thoughts. But here's the catch. The future internet might have no screens at all, sure, but integrating the internet directly into our physical environment, and potentially even our minds, opens the door to monumental vulnerabilities. We aren't just putting our credit cards online anymore, guys. We are putting our immediate physical realities online. With that kind of profound physical and neural integration comes unprecedented risk. Let's look at Section 4, the great digital challenges of a hyperconnected 2050. Right now, policymakers are grappling with some severe vectors of risk. By 2050, privacy and surveillance concerns are going to become extreme as ambient sensors constantly collect data from our environments. We're also facing immense ongoing debates over AI-generated misinformation and who actually controls internet governance. Then you've got the physical cost. Running a planetary AI network requires staggering amounts of electricity, which deeply challenges energy grids worldwide. And crucially, there's the issue of digital inequality. I mean, if neural implants and autonomous wealth generation become the norm for some, we have to ensure this infrastructure doesn't leave half the globe economically stranded. These are deeply complex issues, and regulators, privacy advocates, and tech companies hold very different viewpoints on how to properly balance rapid innovation with fundamental human rights. To really understand why these risks are so exceptionally hard to manage, just consider the sheer volume of devices coming online. Global Internet of Things device growth is scaling from the billions into the trillions by 2050. Every new connected pacemaker, smart thermostat, and autonomous delivery drone is a potential entry point for hackers. This massive expansion exponentially increases the global cybersecurity attack surface, which in turn requires equally powerful AI-driven defense systems just to keep up with the AI-driven cyber threats. It's a constant race. Securing a planetary network on Earth is undeniably one of the most complex tasks in human history. But humanity might eventually build an internet that stretches beyond Earth. So what happens when this nervous system expands into the stars? Let's zoom all the way out to the macro level for our final section. Section 5, an interplanetary nervous system. Think about this. If you try to stream a video or send a standard network packet to a server on Mars today, it instantly times out and fails. The literal laws of physics stand in your way. Light, and therefore data, takes anywhere from 3 to 22 minutes to travel between Earth and Mars, depending on our orbits. The solution to this is delay-tolerant networking, or DTN. It is a completely different network architecture designed specifically to handle massive data delays and constant solar disruptions over extreme deep space distances. So here is how DTN actually functions. Instead of a continuous stream of data, DTN acts almost like a digital space-age Pony Express. It uses a store and forward method. A data packet hops from Earth to a satellite, waits safely in storage until the next communication node orbits into view, and then forwards it on. By leveraging vast satellite constellations like the advanced successors to SpaceX's Starlink or Amazon's Project Kuiper, researchers are actively laying the groundwork for lunar communications and, ultimately, a backbone for Earth-to-Mars connectivity. While an interplanetary internet is definitely a long-term future concept, the fundamental engineering is being tested right now. We've covered a lot of ground today, everything from ARPANET cables crashing on the word login to AI digital twins, all the way out to deep space data routing, and it all leads to this really profound thought from our source material. Every generation inherits a different internet. The next generation may inherit an entirely new digital civilization. The internet is no longer just a destination you visit. It is the invisible, intelligent infrastructure of our future existence, seamlessly woven into the fabric of our physical world. Which leaves us here. The future is arriving faster than ever. As this ambient AI-driven network grows to connect our cities, our minds, and eventually our solar system, how will you navigate the nervous system of tomorrow's civilization? I really hope this explainer gave you a clear, structured picture of exactly what is coming next. Thanks so much for joining me on this incredible journey. Keep learning and stay curious.
Thanks for watching World Decoded. Make sure to like and share, subscribe, and stay curious.